Hey everyone, this is our lesson on magnetism, and by the end of this lesson, you should be able to explain magnetism in terms of domains, interaction of poles, and magnetic fields. So first, let's just review what a magnet is and what magnetism is. I know you've heard these terms before, but let's make sure we have a scientific definition. So magnetism is a physical phenomena produced by the motion of electric charge, and it results in the attractive and repulsive forces between objects. And a magnet itself is an object that is capable of producing a magnetic field. So it's capable of those attractions and repulsions. And it attracts unlike poles while repelling like poles. Some characteristics of magnets that you need to make sure you remember. First are that they have magnetic poles. That's what makes it a magnet. So magnetic pole these are the two ends of the piece of magnetic material where the forces are the strongest. So you guys have seen a magnet. A lot of times you see them like half of it's blue, half of it's red. That's to denote the separate poles. They are going to be on opposite sides of the magnet, and they're labeled as north and south. Remember that like poles I have this backwards. Like poles repel, opposites attract. So we're going to switch these. Okay, so like poles repel, opposites attract. And then the forces that are experienced in this magnetic field will decrease as the distance between the magnets themselves increase. So the further you slide them apart, the weaker that connection will be, or the weaker that force of attraction will be. So now let's talk about types of magnets. The first one is a permanent magnet. This is the one you guys, you see all the time. These are the ones that, it's in the name, permanent. It stays. So this is a substance that will remain magnetized for long periods of time. Yes, some magnets will lose their strength over time, but you can recharge a magnet to kind of help that. But permanent ones should remain magnetic for very long amounts of time. And some examples of these are iron, cobalt, nickel, aluminum, samarium. And then lodestone is a rock that is actually a natural magnet. Another type is a temporary magnet, and this is a substance that becomes magnetized when near or rubbing against a magnet. So you could take a magnet against that material and you can actually magnetize the other. So here, if you look at this little GIF, they're rubbing a pair of scissors with a magnet, and then the scissors become magnetized. But these do wear off over time once it's been separated by the magnet, separated from the magnet for a while. If your magnets get weak, you can actually put them with a magnet, and it will help to kind of rebalance that, rebalance the poles a little bit. So now that we know what a magnet is, let's talk about what they do, which is create magnetic fields. So this is the area around a magnet where the magnetic forces act. So you can see we have a north and a south here, and we have these lines that show the flow of the magnetic field from one pole to the other. So electrons are flowing or the magnetic field is flowing from north to south based on the direction these arrows are pointing. So they are represented by lines of force extending from one pole of the magnet to the other. And we use these magnetic fields to actually use compasses. And these are instruments that contain a magnetic needle that freely rotates in a circle and always points north. So always points north, unless sometimes magnets get thrown off if there is a natural magnetic field around. So like iron ore running through the ground, things like that can kind of throw it off a little bit. But it should be pointing to true north. And then we have what's called a magnetic domain, which is a region in which the magnetic field of individual atoms are lined up together. So this is where we've got your positives and your negatives kind of lined up in a specific order. And when that magnet is broken into pieces, each piece then becomes its own magnet. So if you take this north and south here and you cut it in half, then you'll have a north and south on one and a north and south on the other, it will adjust to form multiple magnets for that magnetic domain. So now, very quickly after that